DC motors. DC motors are popular in applications where you need to quickly speed up or slow down the motor, usually in things like belt drives, gear drives, and conveyor systems. DC motors are usually powered by a DC control board. The control board is usually powered by an AC voltage. The board converts it to DC. The control board will have a separate control, typically a potentiometer, which is a variable resistor, that is used to turn the speed up and down. The motor's voltage rating typically indicates its highest input value. Inside the motor itself, on the end where the DC power is supplied, you will find brushes. The brushes make contact with the commutators. As the rotor turns, the commutators reverse the polarity of the incoming voltage, creating an alternating effect in the supplied voltage. This alternating effect is what creates the magnetic field inside the motor winding. The windings, or armature, on a typical DC motor are on the rotor instead of the stator. The stator typically has permanent magnets that help oppose the fluctuating incoming magnetic field and create the proper impedance in the windings of the rotor. Again, different applications may call for more complicated motors. What I described is your typical DC motor. New brushless motors make the need for brushes go away. Using electronics, the brushless motor's commutator is replaced with sensors and transistors. The permanent magnets are in the rotor and the armature windings are in the stator, similar to a synchronous AC motor. The electronics in the motor, also called ECM or electronically commutated motor, keep the DC voltage applied, switching the polarity to cause the alternating current effect that creates the magnetic field that is constantly opposed by rotating past the permanent magnets. The constant opposition in the magnetic field creates the needed impedance in the windings opposing the current flow. Many DC boards are wired to a speed sensing device like a Hall effect sensor that will automatically adjust the voltage to maintain the selected speed. This type of board would be called a speed control board. In testing a DC motor, you are looking at the input voltage, ensuring it does not exceed the highest rating input and that it maintains the selected speed. Motor failures are typically in the device they are pushing, whether it's a gearbox, a pulley system, or a conveyor belt that gets jammed up. DC motors are very durable, last a long time, and are hard to damage. If they fail, look for the source of the failure to be beyond the motor itself.